Dear student, hello. I hope you are fine and doing well. So in this section we are going to talk about 4.4. It's about L'Hopital rules, indeterminate form in general, so that we will use the L'Hopital rules for it. Now we are starting with the subject, finding the indeterminate form. The indeterminate form is something, we have many types of the indeterminate form. The first, we are going to start with the easiest one. The easiest one is the 0 over 0 and infinity over infinity. So we are using these directly, L'Hopital's rule. L'Hopital's rule. Okay, the state of the theorem is to say that find the derivative of the numerator and denominator separately, then the result of limit of this will be called the limit of f over g. That's all. So for finding this function, for example, I have f of x, or limit of x approach to 0. We have x minus sine of x over x cubed. You can see if I put it directly, I put 0 minus 0, I will get, if I substitute it, so it's equal to 0 over 0. It's the type, first type, what you see, first type. Okay, so in this first type, we have the 0 over 0, and we cannot find anything. So that's why we are going to use limit of x, L'Hopital's rule, is equal to derivative of 0 is equal to 0. 3x square of sine will be what? The sine will change to the cosine of x. Okay, because we are doing separately, so the sine will be 1, and let me write it again, sorry, x equals to 0. 1 minus cosine of x, sine will be cosine 3x squared. Again, if I put 0, I will get what? 0, 1 minus 1 over 3 over 0 is equal to 0 over 0. Again, we can use it another L'Hopital's. Okay, x equals to 0, so is equal to derivative of minus, this is 0, so will be minus sine of x, then this one will be 6x, and again we will get what? Negative sine of x over what is equal to limit of x approach to 0, 6x. And you know, by the theorem or by anything or by another type of L'Hopital, you can see I get 0 over 0 is equal to cosine of x over 6, x approach to 0. So in this case, you get 1 over 6 is equal to 1 over 6, the result. That's all that we need in here about the finding the L'Hopital in the first type. Okay, in the first type. Now, for the rest of the example, I'm leaving this one for you because all of them are easy. Just finding the derivative. You can see here you have a 3, so 3 over x minus 1, and you can see the first derivative will may change to the 3, and the cosine will be sine will be cosine, and x will be 1, so 3 minus cosine will be 3, 1, which is equal to 2 over 1 is equal to 2, and the rest one will be easiest for you. And here's the ABCD. You can find the solution. They are easy, really. There's nothing to be and we solved already this one, so it remains this one homework for you. And the other part is what we have a 0 over 0. Again, we have a notification here. It means that do not stop or do not use the L'Hopital's depending on the exponent. No, depending on the how many 0 over 0 you will get. In this step, I will get 0 over 0. If you are stopping, you will get what? In this step, if I put 0, I will get 1 minus 1, 0 over 0. So I'm going to use the L'Hopital, and I will get sine over this one. In this case, you should, every time you should substitute the value. Otherwise, you will get wrong answer. You will get the error things. Why? You will be, and the answer will be mistake. Why? Because if I put 0 here, I will get 0 over 1, which is equal to 0. That's the result. Otherwise, if you say because I have x is equal to 2, so I'm going to use 2 times L'Hopital, you will get 1 over, which is not right. Okay, this one is not right. So be careful, caution here. Say be careful, because you apply rule currently correctly means that, or each step you should substitute the value. That's why he say please do not use the L'Hopital's depending on the power. For the next page 22, the page section 4.4. In this section also we have what? In this section, also in this page, we have another example on the another type of another type of L'Hopital's. Now we have a 0 over 0. You know, if I put the 0 over 0, I will get a 0. So I'm going to use the derivative. I get what I'm going. Our example will be cosine over 2x. Now if I put a 0, I will get 1 over 0, which is equal to infinity. It's okay. How about this one? I will get minus infinity, because here's a positive, here's negative. So it doesn't mean that if you are using the L'Hopital, the value should be exist. No, maybe there's a undefined, or there's a valuable limit. It's okay. Now the other type, the type B, will be called as a infinity over infinity, 0 multiply infinity, infinity minus infinity. If you get these rules, you can change it again to the other part. For example, we have what? We have x pi over 2, okay, second of x over 1 plus tan of x. You know, if I apply this one, because it's the asymptote for the second, I will get infinity. If I put also for tan and second, they are similar. Why? Because the denominator for both of them is what? Cosine. That's why I get infinity here, and also I will get what? Infinity here. So it will be 1 plus infinity, which is equal to infinity. So I got infinity over infinity. What's the plan? The plan will be using L'Hopital's rule. So then in that case, we have x approach to pi over 2. The second will be second of x, tan of x. Look at, we have a rule of the derivative, you know. And we have what? 1 minus, 1 will be 0, second square of x. And you know, the second will go cancel with that one. And it remains x over pi over 2 over what? Over tan, which is equal to tan over secant of x, and you know tan is equal to sine of x cosine of x, and this one will be cosine of x. Cosine will cancel. It remains x approach to pi over 2 for sine of x, and which is equal to 1, you know. So this is the another method. How about the example 4? We are in the example 4, page 22, section 4.4. So how about B? We have what? This one very important, especially for Cal 2. You need it for those students that they have a Cal 2. Really, they need this subject in the sequence and series. So please do not try to just skip it. Please try to understand it and review it again. In that case, we have, if I put infinity, you know the value of the len will be the infinity. So how about a square root? Also, you know the square root also is going to infinity. So I have an infinity over infinity. How about the solution? The solution will be, what you say, you can find the derivative. Len of x will be 1 over x. How about this one will be, we have a 2 over square root of x, and 2 will remove, it remains what? It remains 1 over square root of x, you know. This one also will cancel out, because I know 1 over x is equal to 1 over x multiply 1 over x, because in general x is equal to square root of x multiplies square root of x. It's okay, because it's equal to x squared, and in that case, if you have a positive, is equal to absolute or x. That's why, okay, this is a note for you. So that's why I removed one of them. It remains 1 and 1 over 1, which is equal to limit of x approach to infinity 1 over square root of x, which is equal to 0, as you know, at approximate value. And I fortunately he write in your lecture, he write this note for you. Okay, so read carefully. Okay, how about the third example C? In the same example, part C, we have a limit approach to e to power x okay, over x squared. I know e to power x, if I am going to infinity, the value will also go to infinity, and if I put this one, x squared will be infinity again. So in that case, we have what we say, we use L'Hopital, which is equal to the same derivative. This one will go to x, and try to substitute again. You get also again what again infinity over infinity. Again, use the L'Hopitals. You will get what? You will get infinity. Sorry, e to power x, e to power, and this one remains 2. Now it's infinity over 2 is equal to infinity. That's the result. We cannot do anything else. So I think I'm fast because easy. We talk about these derivatives in the chapter 3. So for you, you need more review in chapter 2, limit, and chapter 3. So please do not forget about the read chapter 2 for limit, and chapter 3 for derivative. Okay, now we are in the another part of what do you say, another type T, which is very called type B of indeterminate form. So infinity multiply 0 or 0 multiply infinity, and infinity minus infinity. So we finished that one. Now about the examples of this one. The example of the infinity over infinity. So you can, before we start, you can do the chart. Say indeterminate form, type A, which is 0 over 0, type B, which is infinity over infinity, 0 multiply infinity, infinity minus infinity, and we have a type C. I'm talking about it later. So in the type B, we have the first part, the second part. So for example, example 5 in page 23, section 4.4, we have what? We have f of a, part A, of course, a limit x approach to infinity, x sine 1 over x. If I put here, I will get infinity directly, and sine 1 over infinity, which is equal to infinity multiply 0. So it's an indeterminate form, type B. So how we deal with this one? It's very easy. Make the infinity to go to down, okay? Make the infinity to go to the down, okay? So how? I say is equal to infinity. So it's equal to sine 1 over x over x is here. If I put it 1 over x, I should bring it to down, okay? If I do like that, it's very easy. So in that case, we have infinite 0 over 0. You can put 0, 1 over 0. So how you solve this one? How you solve this one? It will be not easy to solve it. So how we change this one? Why the book used another method? Because this one is not, you cannot say is equal to 1. Careful. We in which case we can say is equal to 1 if the x approach to some number, okay, some number, then sine of x over x or theta over theta is equal to 1. Careful, that's why we cannot use this one directly. We say 1. So be careful, try to use some trick. The trick is like that. We have x approach to infinity, 1 over x sine over 1 over x. Okay, so we know if I say let h be 1 over x, it's okay. Can you see that? Why not? I put this one as a h. Okay, sorry, it was x here. In our example, it was x. So I will put h here. Okay. So then, when x approach to infinity, tell me h approach to where? 1 over infinity is equal to 0. So that's why I say 0 from the right side. Okay. So now I'm changing this to h. How? X approach to infinity. So I'm going to say h approach to positive. We change each x to h. Okay. Good. So how about sine before? 1 over x is equal to what? Is equal to h. How about x cross two sides? I get what? X is equal to 1 over h again. So it's equal to 1 over h. Now I have what? Limit of h approach to 0, sine of h over h. So with we now, because we have a number 0, it was number was 0 here, sorry, number was 0. So because I have this number, so 0 is not infinity, I mean it's not minus infinity, we can use the rule we say is equal to 1, positive or negative, it depends, and it's not changed even it's a negative part or left side of the 0. So in that case, if the limit theta approaches to 0, positive or negative, sine of the theta over theta will be what? Will be 1. That's why by this rule we mentioned it before. So in the example 6, so I left this one for you as a homework because there's many things you can do it, you can find it, it's okay. We use the same trick, okay? We have a sine, then just we bring this one to down, nothing happens because I have a 0. So after the derivative you get a 0. Now for example, if I have limit the same page, example 6, page 23, 4.4 section, okay? X approaches to 0, 1 over sine of x minus 1 over x. Now in that case, how we solve this one? If I put 0, I will get infinity. If I put 0 also, I will get infinity. Type B, the third part. Okay, so how we solve this one? X approaches to 0. So we can multiply, or we can find the common denominator. As we mentioned, x sine of x will be over x, and this one need x, and that one need sine of x. So in that case, if I put again, I will get 0 over 0. Look, we change it to this type, to the type A, as we did it here. We change it to the 0 over 0 formula. Okay, so how we solve this one? Derivative of the numerator and derivative of the denominator. The denominator will be what? Because we have a function sine first, multiply the second plus the second, first multiply by the second, so I will get cosine x first, cosine of x, plus the second sine of x multiplied by 1. Okay, how about it here? Derivative of here is equal to 1 sorry, cosine of x. In that case, we are going to use to substitute this value, so I will get what? I will get 0 multiply x, so again 0, so 0 over 0. So I'm going to use the again the limit x approaches to 0, so derivative of numerator will be derivative of cosine will be minus sine, because I have a minus, I have this one. How about derivative of here? First derivative of the second plus second derivative of first. Okay, so first part plus derivative of sine is equal to cosine of x. Now it's time to put 0. So numerator will be 0. How? Here's a 0. Cosine of 0 will be 1. So it remains 0, 1 plus, how about here, 1. So it is equal to 1 over 2. 0 over 2 is equal to 0. So okay, stop it. This is the result. Okay. Now the type C of indeterminate form, type C is power. Means that 1 over infinity, infinity over infinity, 0 in infinity, 0 infinity, infinity 0. So this is the powers formula. Okay, dear. So you can, if you have an idea about how to deal with that cases, you can do it. This one was very easy, 0 over 0, and this one is what's also easy, and this one will change it to 0 over 0. How about now? We have an idea for here. And the idea for type C, you can see the example 7 and example 8 in your page 24. So for example 7, page 24 in your lecture section 4.4, you can solve this one easily. And how about the solution? You can see we have 1 plus x, okay, 1 over x. He say find the value of this function. Okay, first of all we will try to substitute, because I don't know how which case we have. So if I put 0, I will get what? Plus 0. 1 plus 0 is equal to 1 plus infinity, 1 over infinity, right? This one will be infinity. 1 over 0 will be infinity. Approximately 1 over infinity will be infinity. 0. Okay. And the same thing true for my negative. That's why if it's a positive power positive, negative power negative. Now I have a 1 over infinity, so it's a type C, right? Type C. So for solving this one, it's better to say y is equal to 1 plus x 1 over x. Now we are going to try to using ln to both sides. So ln to here, ln to there. So ln of y is equal to what? This one will come down, 1 over x, ln of 1 plus x. Am I right? It's easy. You can see this one is easy. So now to find the limit of x approach to 0, ln of y is equal to limit of x approach to 0 again to both sides, ln of 1 plus x over x. Am I right? So okay. So in that case we will just, because you have an x and there's y, there's nothing to happen, ln of y remains. How about here? If I put 0, I will get ln of 1 is equal to 0. How about if I put 0, I will get 0. So use the L'Hopital again, limit of x approach to 0 from right side. Here we have what? We have 1 over 1 plus x. So put 0 here, you will get what? Ln of y is equal to, if I put 0 here, I will get 1 over 1 is equal to 1. Ln of y is equal to 1. But before we have what? We have ln of y. So we will take this result. After this one, we have ln of y is equal to 1. We will take e to both sides, and you know they are canceling each other, so it remains e to power 1, or it's just e. So the result of limit of x approach to 0, 1 plus x, 1 over x is what? Is equal to e. That's all we needed. Okay, that's all we need. Okay, dear. How about the last example? The last example that we have, example 8 in page 24, section 4.4 is very important also. It's the last example in this section and this chapter. So x approaching infinity, x1 over x. First of all, try to find which type we have. So if I put infinity, 1 over infinity is equal, I mentioned it, infinity over 0. So I have a type C, right? So how we solve type C? By using a ln. How? We say that ln of y is equal to ln of x 1 over x. All right, and this one will go to down, is equal to 1 over x ln of x. You know how. And ln of x. Okay, then later we will take the both side, x approach to infinity, ln of y is equal to x approach to infinity, ln of x over x, right? So in that case, we say have just ln of y is equal to infinity over infinity. So how we deal with this one? By taking x approach to infinity, by taking the derivative, it will remain like that. So ln of y is equal to what? Is equal to 0. Why? Because if I put x approach to infinity, 1 over x will be the result will be equal to 0. I mentioned that. So take the e to both sides, you will see that y equal to e to power 0, e is number, so e to number to power 0 is equal to 1. That's why you get what? You get 1. So here's the result, here's the solution. You can see it's easy. I was very quick in this section because I don't want to take your time a lot, because the subject was not complicated for you. You saw this one before. So that's all about the 4.4, and that's all about chapter 4. Later you will, after finishing this one and sending the homework for you, you will see it's easier for you. Please try to do your best and have a nice time.